Good afternoon, everyone. My name is Tuukka Ahoniemi. It's a weird Finnish name with a lot of vowels and consonants. I indeed come from Finland, and apparently today I was told I look like some character from the Moomins. I have no idea which one, but yeah, I can live with that. So we're going to be talking about a pretty exciting topic, the Internet of Things, and especially what is the cute offering for creating these IoT systems that more or less will define the future of a lot of different embedded industries. More and more of these devices in various industries will be connected to the internet and to each other, and it actually will raise a lot of different challenges and new requirements for us as software developers when we need to create these systems. So that's what we'll be talking today. I personally work in our product management. I've been working with Qt for, 7 years. And my background is in technical training. So I'm also officially certified Qt trainer, which is a nice title to have in business and also outside business hours. But nowadays I mainly focus on our product strategy in terms of different industries, especially the automotive industry, but also looking into industrial automation and IoT, and what sort of technology should we offer for you as developers or business owners or managers to tackle, or like Lars said, to enable you to create the technology of future, not only today. Okay, let's first start with a very relevant question to bring us all to the same page. What is the Internet of Things? So it's a lot hyped term. So I don't think there's an individual embedded conference today where there's not something about Internet of Things. Even we have something about Internet of Things here. We have 3-4 talks, and one of them is about IoT. So there's a lot of hype around it. But I think it's very relevant to have that hype around it. So even though it's slightly futuristic thing, there are already today a lot of items that actually fall into the category of Internet of Things. For instance, I just started thinking that what sort of connected devices do I have at my home? And well, the first thing that came to my mind was my TV, of course. So I actually do have one of these smart TVs, an LG smart TV actually, and I have 2 remote controllers for that same TV, but I also have 3 kids. So the chances are that the remote controllers are quite often lost. So instead of trying to find those controllers, what I can actually do is I can actually just take my mobile phone, my Android phone, and use that as a remote controller for the TV. So in a way, my TV is actually connected. It's a connected embedded device, and I can use a mobile phone or tablet to interact with that embedded device. Okay, so that's a pretty simple use case to have a remote controller for an embedded device. Then I also have a home security system or home automation system as well. And that's actually a pretty common example of an IoT system, well, mainly for homes. But anyway, it features actually a lot of these small and cheap sensors. Well, they were not cheap when they sold them to me, but I bet they were very cheap to create. So these like door sensors and window sensors, and there's a camera, there's a thermometer, so I can now go see how freezing it is in my home in Finland. It is pretty freezing actually over there. And all these connected sensors that are talking to this one gateway device. There is one larger embedded device at my home actually that's then gathering this data from all those sensors, and then it's sending that data to a cloud backend and I can access that data and I can control the device anywhere I am with my mobile phone. So that's like a pretty complete IoT system. You have smart sensors, then you have an embedded gateway, and then you have a cloud backend, and then you have all these client applications running on any kind of mobile devices. Okay, so I already found a couple of these systems from my home, but it's not only about consumer electronics, definitely not. It's about billions of devices going to be connected, and besides homes becoming smart, also a lot of like personal items or wearable items are being connected, like these kind of a health wristbands or whatever wearable and medical sensors. Then cars, those are connected or becoming more and more connected, and there's a lot of data being gathered on how do we use our vehicles, and also that thing is connected to like traffic information, and when we move on with the automotive transition to these autonomous cars, the cars that drive themselves, all this big data is actually being applied there. Then moving on to industrial use cases. So you can have whole factory lines that are actually connected to the internet, that all different parts of that factory line can be remotely monitored and controlled from the other side of the world. Or if there's a problem in one factory in some part, another factory can actually automatically react on that and do something to kind of keep the overall production in good shape. Agriculture is also one of the industries that's kind of quite often, well, I don't know if you can call agriculture an industry, that's kind of the opposite, but in a way agriculture is one of those places where things will revolutionize a lot. You can have tens of thousands of smart sensors in a farm measuring humidity, or individual animals can actually have smart chips, and they can be like controlled and monitored over smart systems and cloud backend systems. So it will revolutionize the whole industry. Also, going from smart homes and cars into smart cities. So complete cities can have these mash-up systems of different items connected to each other and communicating on each other. And here's actually one example. It's from a service called Enevo. They are doing this IoT trash can collection mechanism. So basically, they place these smart sensors to all the possible trash cans in a city, at least the bigger ones that need to be emptied time to time. I bet there are a couple of trash cans in Seoul, for instance, so you kind of get the magnitude. And the idea is that the smart sensor measures how full the trash can is, and based on the fullness of that trash can, they create optimized routes for the guys to clean those up. So instead of needing to do daily or weekly routines of routes, they can actually focus on optimizing their routes based on what parts are full. So that's a pretty neat service. And that's also a nice example of business model. I don't think they actually sell those sensors, but they sell the service based on how many trash cans you have, and on a kind of it's also slightly revolutionizing the business model, that we are moving away from, like in terms of automotive industry, for instance. Maybe in the future people are not paying for the cars, but they're actually paying for the service to use a car, that they can order a self-driving car to their home and for the time that they need it, and they're actually paying for the service and the software and the data based on which they are using the car. So this also can revolutionize the business models, the traditional business models of embedded industries, from product-based to more service-based models. And that's pretty cool. Okay, so that's the big picture. And now moving on to more practical level. So as a software developer, yeah, this sounds cool, but what are we actually talking about here? So if we simplify the Internet of Things purely from software perspective, we're essentially talking about creating an embedded device or some sort of a gateway device and a bunch of smart sensors. And all this gateway device needs to talk to the smart sensors and maybe to other embedded devices as well. And then it also needs to be connected to a cloud or some sort of a backend system. And as there is going to be a lot of data coming, we have to take care of the big data phenomenon. So there's like huge, ununderstandable amount of data coming in. And then that data needs to be accessible through an arbitrary amount of arbitrary types of devices and desktop PCs. Okay, so a couple of years ago when I was an embedded developer, only thing I was doing was this thing here. So I was, writing some hardware related code and maybe doing a screen for that embedded device. And now all out of sudden I need to make systems that, expand essentially to all kinds of devices out there. So the software requirements for creating embedded systems has all out of sudden dramatically exploded. Well, that's interesting. Okay, then what do I do next? I go to an embedded conference. Okay, there are zillions of talks about IoT, and only thing that they talk about are these detailed, mostly hardware related items. So there's a lot of talk about machine-to-machine protocols, cellular networks, RFID, NFC technologies, different security models, Wi-Fi coverage, indoor positioning, these kind of enablers. And these are all important items, but I'm not really being able to see the forest for the trees in these kind of cases. My big question still always has been, what about the software developers? Who is supposed to create all these systems? Who's supposed to write the code and how? That, you can't require us as software developers to do the same thing as before when you've just exponentially increased the amount of requirements for these systems. Okay, good news is that the industries have somehow woken up to this trend. Here there's a comparison of investment in software compared to traditional goods. It actually starts all the way from 1960s, and as you can see, there's a dramatically increasing investment on software compared to others. So clearly the trend is heavily rising. People will invest, or organizations will invest more to software. So there is money for us to use for creating these systems. So software will become more and more relevant in all these industries, which is pretty obvious though. And as the requirements for these systems change quickly, now we get to the other part. So how is this all related to Qt? Well, you kind of guessed it. For the past 10 minutes, I've been telling you about problems, and Qt gives you the solutions for those problems. Well, if not necessarily completely today, but this is clearly anyway our focus within the Qt company, that as we've been doing since the past 20 years, helping you to create your software and your embedded systems as seamlessly as possible, we want to continue to do that also with the IoT systems. So let's talk a bit more about Qt for device creation. So if I understood correctly from Bernie's introduction in the beginning, I don't really speak Korean, so the chances are quite thin, but I think you gave a small explanation about Qt for application development and device creation, because those were the words I could pick up from the Korean. But anyway, So we have these two main product lines. Qt for application development, that's more or less for creating platform independent software like desktop, mobile, and even embedded applications. But then the other main product that we will focus now today in the afternoon is Qt for device creation. So that's when you're creating embedded devices. You're making not only the GUIs, but well, mostly the GUIs, but also the items underneath the GUI, and you're actually shipping hardware. You're building devices, not just applications that run on various systems, but you're making devices. So that's Qt for device creation. And what do we want to offer for people making those devices? First of all, probably the biggest reason why Qt is so popular on embedded creation is in the user interface possibilities. That you can create modern touch-based user interfaces, and it's all running with native performance. So you don't need to compromise the performance side. It's all C++ based, so you have full native access, you have full possibilities in optimizing your code, but you still get a very flexible offering to do touch-based UIs with 3D effects, with animations, with beautiful view transitions. But it's not only about libraries. We also kind of want to focus on the full development workflow. So we're talking about like the complete time to market, and we want to shorten that time to market. And mostly the things we've done since far are related to the actual developer's workflow. How do you work on embedded? That instead of needing to set up your build system and your workflow for a few weeks, we want to provide it out of the box with the Qt Creator IDE. And then when you're doing some development, you're making adjustments to your UI, we want you to be able to deploy immediately to your target board, and if you want to, you can do changes and you can do rapid prototyping without needing to spend hours for cross-compiling and trying to get things to their right places. So this is our big focus area, and that's something I'll actually talk about later today. So let's look at IoT challenges in particular from software perspective. So we had this picture before, the kind of a simplification of an IoT system, and if we start listing on what sort of requirements does the Internet of Things give us as software developers, we can first start with connected embedded devices. So whenever we are doing embedded development, it's always a challenge. I mean, you need to set up your cross-compilation tool chains. You need to kind of build your whole software stack. You need to get a good workflow running. You have all your hardware problems, possible optimization issues with getting the performance in place. Embedded development is always difficult. There's no way around it. But with IoT, we're actually talking about connected embedded devices. So those embedded devices also need to be connected to each other and to a cloud backend, and that also adds another level of complexity. The other problem or challenge is the big data. So basically the amount of data will increase dramatically in the future, and kind of our applications and our systems, especially the backend systems, need to be prepared for the huge amount of data we're getting from these different systems. Then, as we talked about the client applications, the different mobile devices that are used to communicate to these IoT systems, we somehow need to reach all our end users. So the end users can have all kinds of different phones or desktop PCs in their use, and not only today, but if we move forward 5 years, who knows what are they all running. So we also have the problem that besides the embedded system, we also need to get to the pockets of our end users. Finally, a big kind of a built-in idea to IoT is the extendability. In a kind of an ideal IoT system, the system is very, let's say, future-proof, and it's very independent of other systems, but still kind of it's possible to connect it with anything else. So the point being that when you're creating a system now, you in theory should be able to update the system to connect it to other systems that we don't know of yet, or to other protocols that we don't know of yet, or to new sensor types that we don't know of yet. Okay, well it's theoretical, but at least we want to try to do it as good as possible, or as well as possible. So let's say that we create a system that uses smart sensors, and it's deployed to thousands of farms out there. And then 2 years from now, there's a revolutionary sensor type. So you want to update all the sensors, but you don't want to update all the devices. It would be rather nice if you could just change the sensors and somehow have those old systems talking to the newer sensors without needing to rewrite and manually recompile everything to all those devices. So that's kind of a part of the extendability. Okay, let's start with connected embedded devices and what sort of things do we offer from Qt to this part. So first of all, if we talk about the Qt offering, what is it that we actually give for developers? We give out, of course, the cross-platform class libraries. So Qt itself consists of around, 1,000 C++ classes that are cross-platform. And when developers write code with these C++ classes, though that code works on all the supported target platforms, embedded, mobile, desktop. And besides being cross-platform, the libraries are high level, so they're on high abstraction level. So we want our developers to be really productive with those libraries, and working with Qt has always been kind of a fun and very, very easy, so that you can focus on the content that you're writing, not how you write it. But besides these libraries, even though they're the heart of Qt, we also provide all kinds of tooling and pre-made embedded solutions. So tooling is something, like I said, that it's more and more important for us to facilitate the whole development workflow. How do you deploy to embedded targets directly? How do you do on-device debugging? How do you make the development of an embedded device as easy as creating desktop software or mobile software? That's something that Nils will actually show you in practice and talk a bit more today afternoon in his session. Then we also have these pre-made embedded solutions. So we've kind of more or less identified that there are some of these items that most of embedded projects need. And instead of needing to reinvent the wheel every time, we kind of want to give you those already pre-made. So let's take a look at what sort of embedded solutions am I talking about. A very good example of something you quite often need on an embedded device is a virtual keyboard. And well, if you think of it quickly, a virtual keyboard can actually be something very trivial. It's just, letters on the screen that create something for the input fields. That's not a big thing to implement. I can do it in a couple of weeks. But yeah, no, virtual keyboards are actually quite complex. And what we want to provide with the Qt virtual keyboard is a real, not just letters on the screen, but a real full virtual keyboard solution. Meaning that you can, for instance, you can change the layout of the like the visual layout. You can theme it as you wish. You can change the language. It supports all kinds of different languages. You can plug it into a word prediction engine. You can support multiple types of input. So besides just typing letters here, we actually also provide handwriting recognition. So our virtual keyboard actually recognizes handwriting. It also supports 5-way or 2-way navigation, so meaning you can have a joystick or like a scroll wheel. In some cars you have this virtual keyboard where you use a wheel. That's another thing you would need to implement otherwise. So virtual keyboard is a good example of something that most embedded projects need in a way. So when we are providing this for you out of the box, basically we want to take that burden out from your shoulders and let you focus more on your actual development contents. This is very much the direction where we're going with our embedded or device creation offering. Other items we have are, for instance, 2D and 3D charting library, the data visualization library. So you can do these kinds of 3D charts that are either static or dynamic. You can do them also in 2D. Then there's Qt Quick 2D renderer. So as Qt is actually very heavily, or Qt Quick is very heavily based on OpenGL. If you want to take Qt into lower level devices that do not have a GPU, that's a slightly bad combination. So we provide an alternative rendering engine for that, so you can still do it. And something that Lars mentioned that we're working with is over-the-air updates. That's gonna be something very important in the future. Like I said, if you want to update your devices on the fly, and especially with IoT, when you have thousands of different devices out there, you don't want to get them all physically to service. You want to update the software on the fly on the device. And that actually requires quite complex infrastructure to implement. So that's something we've been working with. Another item that we are providing is a full software stack called Boot to Qt. I'll talk about that soon. Most of our tooling is directly integrated into our Qt Creator IDE. How many of you actually have used Qt Creator? All right, quite a many. So Qt Creator is it's our IDE that's directly made for Qt projects. You can use the C++ libraries, of course, with any IDE or editor, but especially on the embedded side, Qt Creator lets you directly configure your tool chains, your cross-compilers, and create kits out of these so that you can just switch kits dynamically and directly deploy to your target device. Or then if you want to deploy to desktop, you just switch the kit and press play, and then you're running the same software natively on your host PC. Nils will actually show you that in practice later today. So Qt Creator is it's kind of becoming the heart of all Qt development, especially on a desktop side, and it's actually became so good of an IDE that just regular vanilla C++ developers have adopted Qt Creator to be their C++ IDE as well. So it's also used a lot outside Qt projects, and I think that's a really good thing. We're very proud to host kind of all the development work for Qt Creator as well. It's also part of Qt project, our open source model, so that's also open for contributions if you're interested in that part of Qt. But let's talk a bit about boot to Qt. So, big part of our offering nowadays is kind of at the direction where we want to offer a whole platform instead of just libraries that you configure your platform for. So a couple of years ago we started this project called Boot to Qt, and the purpose of that project was to create our own software stack. Okay, since then, well actually since the past 3 years, the stack has been modified a lot, and we've kind of searched the right direction and the right combination for the stack. But today it's in a really good shape. So what we are offering with our device creation package is actually a full embedded Linux software stack for a set of reference boards. But the whole stack is based on Yocto project tools and Yocto project recipes. So actually what we're giving you is a good kickstart for your own production stack. And the idea is that when you install Qt for device creation, you select that what is my development board, and you get a full pre-built image for your board. So then you just flash a memory card and insert it into your device and launch the device, and your device is running Qt demo launcher. So your device actually has the whole middleware and embedded Linux and relevant middleware and Qt on top of it running already right after installation. And besides that, your Qt creator is already pre-configured to work directly with that board. So you do not need to set up any cross-compilation tool chains. You do not need to configure anything. You actually just write code, press play, and you're running Qt on your embedded device immediately. So this is the starting point, that in just after moments after installation, you are running your software on the actual hardware. Okay, but then of course when we're doing real production projects, we always have something custom in our hardware, but that's where the Yocto part comes in. So what you do is then you just take our stack and you use that as a kind of the first step, as a good kickstart, and you configure that to your specific hardware needs and you optimize it to your production stack. But anyway, you're up and running since day one with the actual hardware. Okay, the connection side of these devices, how do you then connect an embedded device that's built with Qt? Well, first of all, within an IoT system, when you need to talk to, you have your embedded device and you need to talk to your hardware or these smart sensors, we already provide a lot of connectivity related cross-platform modules. So there's networking module, there's Bluetooth that also supports Bluetooth low energy or Bluetooth smart. That's today probably the most common protocol for talking to smart sensors and wearables. Then we have a serial port API. We're introducing a serial bus API that will have, well, in the first release it will actually have the CAN bus for automotive, but we're working on a Modbus implementation for industrial automation, also looking into FlexRay, OPC UA, these kinds of different bus protocols. And we have an NFC module, and probably in the future we will have other modules as well for all the relevant kind of communication mechanisms to smart sensors. Anyway, as Qt is C++, it's very easy to mix and match kind of a native Qt code, native C and C++ code with Qt code. So if we don't have an API for something that you want to use, you can always just use the native implementation to do that in the middle of Qt code. So we're not restricting to use anything else. We're just making some things a lot easier. For connecting outside Qt, the networking module is of course relevant, but what is quite often used is a set of different RESTful APIs, and Qt 5 has a built-in JSON support, and we also have our own web engine, a browser engine called Qt Web Engine that lets you then show HTML5 contents directly in your user interface if you want to show something back. Okay, let's move on to big data. So here's another chart. Apparently it's quite difficult to read from this screen or from this projector. But basically here are years. This is 2015 here. This is 2020. And this is showing worldwide data growth projections. So how much data is there? Today in 2015 we are in around, I don't know, what is this, 12 exabytes. I don't even know how much an exabyte is, but I bet that's a lot. Anyway, if we move on 5 years to 2020, we are in 40,000 exabytes. So that's like over 3 times the amount of data we have today. So in just 5 years, the amount of data will be, if not quadrupled, then at least tripled. And I would say that's a serious issue actually. So kind of a key enabler of IoT is how in general the big data big data technologies are emerged for analytics that enable enterprises to actually benefit of this big data. From Qt's perspective, it's something that needs to be recognized, but usually it falls slightly, outside Qt scope. Usually the big data is more relevant to the backend systems. Now, naturally you can write web services with Qt as well, but that's not where Qt is traditionally used. So in a way, this is more of a problem of cloud systems. But for the client APIs and for Qt APIs, what this basically means is that the Qt libraries and, for instance, the visualization libraries, they need to be capable of handling large amounts of data. And more or less, that's what we are doing. So we've already had a lot of experiences in handling large amounts of data. We have a lot of kind of a visualization industries that are using all the different Qt GUI and 3D libraries, and they tend to have a lot of data, as well as research institutes that are collecting samples from millions of different items, and they need to visualize it all at once. So in a way, for years we've already been preparing for the big data within our libraries. But I would say that most importantly, this is something that when you write your applications, and especially your backends, you should keep in mind that how well do I scale? How well does my system scale for big data? Or is big data relevant for my system? If you only have your 3 sensors and you think that you will never have more, then maybe you don't need to scale. Depends on the use case. Okay. Then reaching end users. How do you, when you're creating those client applications, how do you get a big audience for them? Well, that's what Qt is for. Part of our promise is, or kind of our value proposition is, in general, is to get your application or your software service to all the screens of the end users. So, hey, Qt is cross-platform. So with the cross-platform, if you make your client applications cross-platform with Qt, you basically get immediate market reach, and you do not need to prioritize between platforms. There are a lot of these different product managers or project managers that come to me and basically say that they're struggling because the mobile markets are very fragmented, not only between different operating systems, but also inside or within an operating system. That there are all these various kinds of different Android devices that they would need to target, and whether they should first target phones or tablets, and what's the status of iOS? Is that still relevant or not? How about Windows Phone? Is someone still using it? So with Qt, you do not need to make this kind of prioritization. You don't need to have a separate team of Android developers and another team of iOS developers. You can focus on one technology, and your client application will actually run natively on Android, iOS, and Windows Phone, and of course desktop platforms as well. Part of this is also kind of allowing this multi-screen development, that when you're writing software that's, let's say, well, it's running on desktop PC, embedded device, and a mobile phone. Okay, if you write it with Qt, it will run on all the different screens all at once, or as is with the same code. But I'm not sure if you want to run a desktop UI on a small mobile phone screen. So in a more realistic case, we're talking about maximizing the code reuse. With Qt, what you can actually do is when you're using Qt Quick, Qt Quick kind of separates the UI presentation layer, the QML layer, from the actual business logic of the application, which is usually written with C++. So what you can do with Qt Quick is, if you make these kind of IoT systems, for the embedded device, you will write your own backend, well, not backend, but you will write kind of the application engine side, the C++ side for the embedded device. This will communicate with all the hardware peripherals. It will handle the communication to the sensors, and then it might have a screen or might not have a screen. Sometimes they are headless gateways. Then for the actual client side, you write a separate engine that basically talks to the cloud backend, gets the data and visualizes the data, and maybe if you want, you can also have like remote controlling back to the cloud backend. So for the UI side, for both of these, you can actually reuse the same code. What you can do is you can use the different, you can write these common UI parts, like different UI controls, themes, and the UI logic into one kind of a unified structure for all of these different screens. And then what you do is only the thinnest presentation layer, the layout of the items on the screen, is different for the different screen types. And basically, all these underneath parts are pretty much 90% or 95% of the whole code. So only the remaining 5 to 10% is then different for those different screens. And essentially what you're doing here is you're anyway writing the whole system, the embedded device, your client applications for mobile and your client applications for PC, all with one technology, reusing the same code base. So this is pretty much where we kind of want to go with Qt and IoT, that you can actually use the one technology for all parts of the different system. The final part is then the extendability that I mentioned. So what does this mean from IoT context? It means that you should be preparing for future platforms. You might want to update the hardware, the sensor hardware. There might be new communication protocols or sensor protocols, or then you might need to be hooked up to new system connections or backend systems. So with Qt, the kind of a future-proofing your software for future platforms is pretty much implicitly guaranteed. So we, as a cross-platform framework creator, we have a pretty good incentive to port Qt to any relevant platform out there today and in the future. So if you write your application using Qt, you can pretty much be sure that Qt will also run, and your application on top of that will also run on all the relevant platforms of the future. So for instance, an example of this is Windows 10. So if you've used the older Microsoft offering and written your applications with the Win32 APIs, now Microsoft is moving their developers more towards the WinRT developer offering for creating the modern Windows 10 and Windows 8 applications. Within that Microsoft ecosystems, developers are now encouraged to port their applications from Win32 to WinRT. So even within one ecosystem, you need to port your application to a future platform. But as Qt supports both of them, if the original application is written with Qt, it will actually already be ported. So Qt actually gives you this migration story from current platforms to future platforms as well. Then for new APIs, for new hardware, kind of the Qt APIs, how we've designed these, for instance, with the sensors, is that most of the stuff is plugin based. So for instance, the sensor API is using plugins. You have plugins for all the different sensors in a phone or in an embedded device. And basically, if you want to add new sensors, you just add a new plugin to that API, and dynamically your application can handle those new sensor types. I mean, this is plugins are something that are very often used for these kinds of problems in embedded development in general, but also the Qt APIs themselves are plugin based, just to avoid these kind of problems in the future. Okay, a short summary. So how do you build IoT systems with Qt? What sort of items do we provide for developers that are doing IoT? First of all, we have the high-level C++ libraries that give you native performance, easy access to hardware and sensors. Things like networking for connecting to your back-end systems, and also HTML5 integration. Then we have all the libraries for creating those beautiful user experiences for the embedded device, but also for the mobile clients and desktop clients. And like I said, you can actually reuse the same code structure, and with some architectural design, you can reuse up to 90% of your code between those different platforms. Besides those libraries, we've put in a lot of effort, and we'll put more effort into tooling and embedded solutions. So you get Qt Creator, you get easy on-device deployment, debugging, and kind of integrated tool chains. We give you the boot to Qt stack that you get out of the box, and you can immediately start working with your embedded hardware. But then we also give you things like virtual keyboard, charting libraries, on-the-air, over-the-air updates, and these kind of items. And all of these are cross-platform. So that's pretty much it. So with that, I thank you for listening, or 감사합니다, or something like that.